to my colleague Angelique Herring, who is in Holton, Maine, where I hear you have some pretty good weather.
Hello, Daryl, and welcome everybody to Maine. That's right, we do have some great weather. We are here in Maine, and actually we're about 3 miles away from the Canadian border, and also about the last stop on I-95 North. So we're the northmost spot for today's Eclipse broadcast, at least in the United States. And so hello from way up north. Now, just like Daryl said, we do have some excellent weather here in Maine today. We've been here for a couple of days, and it's actually been pretty wintry right up until about yesterday. We had snow, it was pretty cold, but you know what? Today, the sun is out, the skies are blue, and it's looking like perfect conditions for an eclipse, or as the Mainers would say, wicked good weather. Now, we're actually standing here in Market Square in Maine, and we are outside of the Temple Theater, where it has actually been in operation since 1919. Over the last 150 years of its operation, it's seen everything from silent films to burlesque shows, and today, it's got a more celestial show with the eclipse. Now, the last eclipse to come through Maine was actually in 1963, and that eclipse was only visible for about a minute. In contrast, today's eclipse will be visible for at least just about 3 minutes or so, so everyone here is going to have a lot of time to take in the celestial show, really soak in the event. And the next eclipse won't be coming through Maine until 2079. So it makes a lot of sense that we've got a lot of people here really excited to see this once-in-a-generation opportunity and event. We're all excited. I know everybody here is excited. So we'll be here waiting for the moment that we've all been waiting for, the eclipse. With that, back over to you, Megan.
Hey, thank you, everyone. It was really cool to see everyone along the path of totality. You can tell we're covering a large swath of land because everybody's in different kind of attire. You know, you have short sleeve shirts somewhere, and then you have like Daryl, who it looks very, very cold, and he does have some cloud cover, so I hope that it does kind of clear out for him.
I feel like we've covered all of those levels of weather over the last day and a half.
That's true, here in Cleveland. So, but it's looking nice now, so that's great. And actually, if you were watching our screen here, we just had a view of the eclipse in Mazatlan, Mexico. In about 10 minutes, that's when we'll start seeing totality in that area. And in that time, the U.S.'s top doctor is encouraging everyone to try and watch the celestial event for our physical and mental well-being.
Hi, everyone. I'm U.S. Surgeon General Dr. Vivek Murthy. I'm thrilled to be joining you today as you gather to experience a truly awe-inspiring event, the last chance that we'll have to see a total solar eclipse in the contiguous United States for the next 20 years. The sun is a universal source of light and life. It contributes to our physical, mental, and emotional well-being, and it unites all of us. Today, no matter where you're watching from, whether it's along the path of totality or a partial solar eclipse, you are sharing the experience with millions across the nation. And moments of connectedness like this truly matter. Last year, I issued a Surgeon General's advisory warning about the public health crisis posed by loneliness and isolation. I shared that our connection with one another is a powerful force that can help protect against the damaging physical and mental health impacts of loneliness. What better reason is there to come together with friends and loved ones than to share a once-in-a-generation experience like the solar eclipse? This is an experience that will stay with you, precisely because of the awe that it inspires. Awe allows us to step outside of ourselves, giving us fresh perspective and opening us up to connections. So grab your eclipse glasses and let's enjoy this moment together.
Some great advice. Thank you so much. All right, we have time for other hashtag Eclipse questions. Sarah, are you ready?
I am absolutely ready.
All right, let's take a look at this video from a familiar face.
Hey everyone, I'm Scarlett Johansson, and I play a NASA Public Affairs Director in the new film, Fly Me to the Moon. I hope everyone is safely enjoying today's eclipse. I actually have a question about the moon for NASA. So during a total solar eclipse, I've heard that craters and features on the moon play a role in what viewers see on Earth when the moon blocks the sun. So why is that?
Question, Scarlett. So yeah, as we, the moon isn't a smooth marble. It actually has big, high mountains and valleys, these craters. And as we approach totality, sometimes you'll hear people talk about Bailey's beads, and these are the last few moments of sun creeping through those deep valleys.
Yeah.
Just before we hit totality.
Yeah. Absolutely. Thank you so much. It's so great to have you here to answer some of these questions, and we plan to take more. If you send them in, #Eclipse again. Okay, if you're just joining us, I'm NASA's Megan Cruz, and this is NASA lunar scientist Sarah Noble. And as you can see, you are watching the official NASA broadcast for today's total solar eclipse. And we are in the heart of downtown Cleveland, where NASA is celebrating this celestial alignment. Take a look at our shot from the air. That is how many people who are just here at the Great Lakes Science Center alone. So many more spread out throughout Cleveland, because again, the last time this city had a total solar eclipse was 1806. But again, just down the road, we have the only NASA center in the path of totality.
When it comes to NASA, I think a lot of people initially think of rocket launches in Cape Canaveral or astronauts floating above the Earth in the International Space Station. But there's a lot of research and engineering and testing that needs to happen before anything can fly. And we have those capabilities: supersonic wind tunnels, microgravity drop towers, vacuum chambers, and a research aircraft hangar. And that's why people from all over the world come to NASA's Glenn Research Center right here in Cleveland, Ohio.
What we work on: power, propulsion, communications. You need it for anything that flies.
We like to say the road to the moon goes through Ohio, and that's because our test facilities are crucial to advancing the Artemis program.
Part of our vision for going back to the moon and establishing a sustainable presence is having a lunar gateway. A lunar space station can fly successfully around the moon and sustain astronauts there. And we are leading the program that's developing the power and propulsion element.
NASA's Neil Armstrong Test Facility in Sandusky, Ohio. It's the only place in the world where you can test a full-size spacecraft for all the extreme conditions of launch and spaceflight.
Right now we have the Orion spacecraft. This is a spacecraft that actually went around the moon, but we're using it as a test article now to make sure that in the launch environment, that spacecraft is safe.
When it comes to aviation, every U.S. plane has NASA Glenn technology on board, which makes your flight cleaner, safer, and quieter.
And looking at solutions like electric and hybrid electric propulsion systems that will reduce or give us different ways of converting energy that are cleaner.
Our center partners with a lot of community organizations to share NASA's discoveries or just get kids excited about science, engineering, technology, and math.
I really enjoyed the VR experience. It was really cool to be able to sit like I was an actual pilot flying. I feel like I could potentially look into considering aerospace.
We've also made it our mission to prepare Cleveland for the April 8th total solar eclipse.
We demonstrated different types of hands-on activities for educators to share with their students, as well as the science behind a total solar eclipse.
My favorite thing about Glenn is our people. Not only are they crazy smart, but they are genuinely good people. And we are literally part of almost everything NASA does. And so what's really great about being here is you're in the heart of it all.
And joining us live is now NASA Administrator Bill Nelson. So great to have you here for this celestial event. Thumbs up. Thumbs up from the Administrator. Now, Administrator, why are solar eclipses so unique, such a unique opportunity to study our sun?
Because you have the alignment of three celestial bodies, and unique things happen when that occurs. And it has a profound effect here on Earth. Just think about it. The middle of the day, all of a sudden, it gets totally dark. And us Earthlings are not accustomed to that, and nor are the other little Earthlings.
Right.
All the animals. But it's also an opportunity for us to study much more one of those celestial bodies, and that's our star, our sun, and our star in our solar system. And we can find out more about that gaseous explosion that's coming out from the core of the sun when we can see it better. And we can see it better because we're not looking at the bright ball. You're suddenly looking at that corona, that mass of gases that are coming out from the edge of the sun.
Right.
And you don't have to be a scientist, right, to study this event, right? How do we get help from people across the country to help us study these things?
Well, by asking them. Make a note of anything that you observe and then share that with us.
All right, an administrator, you know, we have to take precautions when viewing a solar eclipse. Remind everyone what we should be doing today.
Okay, you've got some glasses.
That's right.
That's right.
The glasses
We're
are
all ready.
absolutely essential. You want to put these on as it is starting to have that moon move in front of the sun, and we don't want you to damage your eyes.
Right.
And it's incredible. You put these glasses on in the normal sun of the day, you can't see a thing.
Can't see a thing.
But when you look at the sun, you will be protected.
Administrator, thank you so much. We really appreciate your time here. And now we're going to head it back over to James at the Eclipse board.
To the things that they can do.
Whew, yeah, the countdown is on. Just a few moments left until the eclipse makes landfall in Mazatlan, Mexico. Right here, you can see where that eclipse totality shadow is right here. It's going to continue moving very rapidly onwards to Torreon, where we also have a live feed covering all of this event. Super excited for that big moment. And let me actually just go to our moon board here, and we can play through this at 60 times speed. I'll zoom in a little bit here. And Scarlett Johansson had a question a bit earlier about the kind of rippling effect that we see of the eclipse shadow. When you first see this right here, at first glance, you might think it's low resolution or lacking some kind of information here. The inverse is actually true. This is actually incredibly high resolution, this shadow projection that we have, because of data that we've been gathering at our moon for more than 10 years, thanks to an orbiter called the Lunar Reconnaissance Orbiter. It's been mapping our nearest neighbor in incredible resolution, just really getting every single bit of valley or crater or mountain. All of those little imperfections on the moon are contributing to that shadow that we see rippling across the country. You're not going to be able to see that from the ground, but looking from space, you see that really cool effect of kind of the rippling there here. So let's just preview some things to come here. In Mazatlan, they have that last little crescent sliver of sun. For now, if you're in that area, make sure you keep your glasses on until that sun is completely blocked out by the moon. That's going to be in just a few moments. You're going to have a long duration there, 4 minutes and 17 seconds. That sounds like a lot of time, but it's going to move like that. So make sure you are ready on the pulse. Again, for all of our locations up on this path of totality here too, make sure you set a timer on your watch or a phone or something to remind yourself to look outside and experience this. You don't want to miss this. If you do miss it, you got a long time to wait for the next big one across America. That's going to be in 2045. So make sure you're watching and watching safely here. You just saw some footage from Kerrville and Cleveland as well. It's a little bit cloudy in some places, really hoping that that clears out in time for us to have that beautiful view. But in just a few moments right here, this eclipse is going to be coming up in Mazatlan, Mexico. So for now, this is going to be really exciting. The countdown is on. So for Mazatlan, this is the last little bit here. Again, I'm always keeping an eye on that weather. And also one little note about our tool here too. If you wanted to see, this little icon kind of previews what the expected eclipse is going to look like at that given time. All these little googly eye features are clickable, hyperlinkable. You can kind of click on that. It'll snap you right to that exact time to get an idea for what it's going to look like in your neck of the woods. But for now, the big moment's coming up. Back to you, Megan. Let's check it out.
All right, thank you, James. And as you can see, wow, we just have a tiny little faint sliver left of the sun in Mazatlan, Mexico. We are expecting totality in 1 minute and 35 seconds. You know, joining us now to walk us through this, Kelly Korrick, an astrophysicist with NASA's Heliophysics Division. Kelly, tell us about the science NASA is about to conduct right now in Mazatlan.
So science that they're going to conduct is about the WB-57. So we're going to fly some planes over and make sure that we can actually see that solar corona, that hot atmosphere that's around the sun that we're about to get once we reach totality.
Yeah, and it looks like it's almost there. Yes, it's almost there. You know, we have a view right now of inside the cockpit of one of the WB-57s, or at least we're efforting one, because as you said, this is going to be a huge part of what we do in Mazatlan.
Definitely, yeah. It's the
there it is, Kelly.
There it is. Oh, look at that view.
So we're looking out.
That's great. We're looking out, and it looks like we might be able to, we're seeing a lot of clouds, but hopefully a shadow as well as we're coming in to totality there. And so, yeah, so these WB-57s are carrying 3 different instruments or 3 different experiments, 2 to look at the sun and 1 to look at our atmosphere, because our atmosphere actually responds to the eclipse. And we're trying to figure out how that ionosphere, that layer of the atmosphere, actually responds to it.
And you said it does look like there's already a shadow over land. You know, we also have a shot, and we'd like to pull that up now, a shot of the coast and the fact that it's already going on over. And you know what's really cool about all of this is we do have eyes all over this thing because we are collecting so much data.
Yeah, definitely. I mean, we have the stuff here. We also have rockets on the other side of the country being launched. So again, study that. Oh, look at that. That's the diamond ring.
That's right. We're not there, but I feel the energy just watching it.
Yeah, so this is because of the craters and the peaks and valleys of the moon, we're seeing the last bits that are just getting through, and now we're getting to totality. This is great. So you're starting to see those pink fingers out there kind of sticking out.
Wow, so again, totality here in Mazatlan, Mexico, the first community in North America to experience the moon completely eclipsing the sun. And if you are in Mazatlan right now, it is now safe to remove your eclipse glasses for the next 4 minutes. And you mentioned some of those pink filaments that we're seeing, right? Can you talk us a little bit through that, Kelly?
Yeah, so those pink filaments, because they're helium-rich, that's why they're appearing pink and they're hanging out there. Those could be the start of space weather. So there are lots of tons of material, billions of tons of material that could possibly be one of those explosions for space weather. The reasons why we really study the sun and try to understand how to live with the sun.
Well, can you explain why space weather is important to us here on Earth?
Definitely. So it's not just satellites that are interested in space weather. It's also our power grids because of those energetic particles coming from those big explosions that can happen in the sun. That could damage our power grids. It could also do things like interfere with GPS signals. And I know we all use our phones to navigate everywhere. So if we didn't have that, that would be a big problem. So we're looking to understand it better so we can all mitigate all those things.
Some of the movement we're seeing here is just our telescope operator adjusting because, again, they needed to make some changes for before totality. Now they're viewing it a different way, and then after totality, we might see some shakes there as well. But I really just cannot believe how crisp it is. As we said, it's not a marble, but I mean, just the view of it is so crisp with these little, again, those filaments are just amazing that we can see that to such accuracy, you know?
Right, definitely. And also the white fuzz. I mean, you're seeing something that's 1,000,000 degrees just hanging out all around the sun. And, you know, 3 billion Earths can fit inside of there. So there's a lot of atmosphere there, all around there, just hanging out, being very warm. And so, one of our mysteries is, and one of the B-57s are addressing.
There you go, WB-57, our pilot.
Yeah.
He's flying. So basically, Kelly, he is going to fly and try to chase down the shadow for as long as possible, keep up with it as long as possible.
Exactly. The shadow is much faster than the plane. However, they can chase it for a while and get an extra 2 minutes. So on the ground, we can only get 4.5 minutes, and they're going to get 6.5 for that plane.
I love that they're waving to us. Oh, there you go. And now we're flipped. Now we're seeing the front. So again, they are in night. I mean, it looks very dark with only some light in the horizon, yeah?
Right, yeah, and that's what we'll expect wherever we see totality is the night sky is very dark. You might even see some planets or stars, and then you'll see like twilight all around in 360 degrees.
What an amazing vantage point as well. My gosh. I'm very jealous. Kelly, are you jealous? I kind of feel like you're jealous.
I'm kind of a little jealous. Yeah, I kind of want to, see if I can make a faster plane so we can, follow it the whole way.
Plus, they're up above the clouds, so they don't have to worry
about the clouds. Exactly.
Well, I do want to say a big thank you to the WB-57 pilots and the whole team supporting them for that great view. That was awesome. Kelly, you have a wealth of knowledge when it comes to the sun. And for those watching, if you're interested in learning more with her, check out her and other experts featured in the Sun series of NASA's Curious Universe podcast. And that QR code will pop up on the screen, and that'll take you straight to the episodes. Again, look at that double box we got there. We're showing you amazing views during this broadcast. A big thank you, actually, to the Solar System Exploration Research Virtual Institute, or SERVI, for providing the telescope views from Mazatlan.
Yeah, the survey team down there, the survey team is based out of Ames, but it is a collection of teams across the country and across the world that are sort of studying the...
So hopefully we'll be able to see that in Torion right now.
Yeah, we're watching that live feed.
Yes, just to see this sliver crossing over the moon.
That's right. We're getting so close there.
We are
Hopefully
getting
we'll see
so
that diamond
close.
ring too.
Wow. Look at this. And so we're about 10 seconds away.
Here we go.
Let's take it in. Wow. What a spectacular.
It's going into totality.
Wow. There you have it. We are in.
Yep, that diamond ring came through, and we see a little bit of those Bailey beads too as we're looking at it. Those kind of the lights trickling through around the surface of the moon, coming through the peaks and valleys.
So what are we viewing on the left-hand side? This almost pink color effect.
Right, and so as we just heard from the last totality, you know, these pink fingers are popping out a little bit, and those are those solar prominences. They're appearing pink because of the helium rich, but we can see it. Let's focus on the corona here, that glow that we're getting, and we can see basically these streams that are coming out, a lot of that energy and brightness that we do not have the ability to see on a day-to-day basis. So with this total eclipse, we're able to see that corona nice and bright coming through in Torion. That decrease in activity going back down to solar minimum.
And so, Gina, I've got time for one more quick question from Christopher on X, who wants to know which other planets have the best eclipses.
Oh, okay. Well, that's right. So eclipses don't only happen on Earth. Let's talk about Mars for the fact that Mars does have eclipses when the moon crosses in front of Mars. Mars has 2 moons, and the rovers on the surface have captured images of those.
But no other planet has a view quite like this, right?
Nope, that is special for us. Just the distance and the size of the moon makes it such that it will completely block the sun as it's doing today.
Wow.
And you can see there's that diamond ring effect as we are coming out of totality in Torion.
What an incredible
Wow, it's a bright one too. Look at that.
That is a bright one. So is this what, a Bailey's bead, or?
So that's going to be that diamond ring, just how bright it is. Bailey beads are a little bit smaller as they kind of bubble over the surface, but folks who are in that location should have those safety viewing glasses back on so that they can now view the partial eclipse that they are experiencing.
Well, that is fantastic. And you know, the next time we see this eclipse, it's going to be right here in Kerrville, Texas. So folks, the countdown is on. We've got about 10 minutes until we see this with our own eyes.
You can hear people
Yes, big moment right here in Kerrville. For now, let's check back in
the Indianapolis Motor Speedway. But we're joining with millions of people around America looking up together to the sky.
Absolutely. And tell me, is this your first eclipse?
It's not my first eclipse, but it will be my first totality. I've seen several partial eclipses, but there's something mystical and mysterious and in some ways unifying about a total eclipse, and we're all going to feel it together.
Astronauts safe. What is space weather, and why do we care about it? What is NASA doing to study it?
Yeah, that's right. It's actually very important. It is of concern for astronauts who are in space because they experience the radiation of the sun that comes from solar flares and solar weather. But the reality is it's also affecting life here on Earth. It impacts the upper reaches of our atmosphere called the ionosphere, which is an electrified part of our atmosphere that is a conduit for communications. It's critically important. It can even affect power grids. And of course, if you ever have seen the Northern Lights, you've seen the effect of solar weather. But really the focus for today is where that solar weather starts, and that's in the corona, the sun's atmosphere. It's very unusual, and we don't exactly know what's happening because the sun's atmosphere is millions of degrees hotter than the surface of the sun. So we are hoping to learn today more about how that happens and why that happens so that we can better predict those solar flares and those things that impact us here on Earth.
Yeah, that's all extremely important and something that we're learning a lot today too. Pam, thank you very much for joining us today.
Thank you.
As we've learned, solar eclipses are very important to learn for many, many reasons. We have radio telescope operators who are studying the eclipse today for this very reason. Let's take a look at that work.
When the moon blocks the sun during a solar eclipse, there is a noticeable impact on Earth's upper atmosphere, known as the ionosphere. These changes can affect radio communications, including amateur radio, also known as ham radio.
Ham radio is a way you can talk to people all around the world. You set up a radio and antenna. You talk into the radio sends a signal up to the antenna sends the signal up to the sky. It bounces off of the electrified layer of the sky back down to Earth, where you can talk to the person on the other side.
During the 2024 total solar eclipse, the HamSci Citizen Science Project is inviting ham radio operators to transmit radio signals. The goal is to have people make as many radio contacts as they can with operators in different locations during the celestial event. By recording how strong their radio signals are and how far they go, ham radio operators and scientists can learn about how the ionosphere changes during solar eclipses.
Sometimes you can talk around the world and sometimes you can't. And that's all based on what the ionosphere is doing, what the sun is doing. When it works and you are able to talk to these faraway places, I find that really magical.
To learn how you can participate, follow Do NASA Science on X and Facebook.
And we are minutes away from the total solar eclipse over Kerrville, Texas. The temperature is dropping. As you can see, I have to throw on a jacket. The sky is dimming. We're on the edge of our seats, and we are joined now with astronaut and commander of the Artemis II mission to the moon, Reed Wiseman. Reed, it's an honor to have you here.
Thank you. The crowd noise, like the fact that the sun is behind the clouds most of the time and peeking out, it's so wonderful.
I know.
True. Thanks for being here, Reed.
As you can hear, like, we are ready.
We are right there.
So exciting. So tell us, Reed, obviously everybody is excited, but have you seen a total solar eclipse before?
Never a total, so I will share this darkness with you and this whole crowd the first time.
Wow, this is incredible. So, too, what considerations do you and your fellow Artemis astronauts need to think about when related to the sun when traveling back to the moon?
Well, it's great to see Pam Melroy on your last clip, a dear friend of mine, so it was nice to see Pam's face over there. But when we're heading out to the sun, it's really radiation is our big thing that as we're heading out to the moon.
Yeah.
It's really the solar
sun.
radiation that we're most thinking about there as the danger from the sun, and the Apollo astronauts dealt with it, and we've dealt with it for a long time on the International Space Station, and we have a lot of data from the moon from our NASA probes that have gone out there and collected, so we think we know what we'll encounter.
Great, okay. And tell me, Reed, how does it feel to be the commander of NASA's first crewed mission going back to the moon since Apollo?
I am flying with Victor Glover, Christina Cook, and Jeremy Hansen, the dream
team, yes.
I know, so every day that I go into work, I won't say every day is easy, but every day is fun, and I'm flying with people that have principles, they have integrity, and they have just so much knowledge and professionalism. It's a dream come true. And getting to work with the whole team, the international team, it's the best.
Wow. Well, thank you so much for being here with us, Reed. Really quickly, do you have any advice for anybody that might want to follow in your footsteps one day?
We always say that you have to find that job that you love, go all in on it, live your best life, be as good of a professional as you can, and someday apply for the program. And we look forward to seeing your application come across our desk.
Thank you, Reed, and good luck on your upcoming mission.
Thank you. Great to be here.
Now, if anybody feels like reaching for the stars, NASA is actually currently accepting applications to be an astronaut. You could one day travel to the moon and eventually to Mars. From teachers to scientists to even those in our armed forces, we are looking for a diverse group to take humanity farther into the cosmos. You can apply now through April 16th by visiting go.nasa.gov/astro2024. Now, timing is everything when it comes to pulling off successful science during an event like today. Let's hear from a very special guest who also knows a thing or two about perfect alignments.
Hi, I'm Paul DeYoung, shortstop for the Chicago White Sox. What does it take to do my job? You gotta know your physics. I specialize in predicting the path of fast-moving objects at a split-second pace. At my position, it's key to know exactly where and when two paths will cross. Just like NASA needs to know when the Earth, Moon, and Sun will align to predict the solar eclipse. Working it all out on the whiteboard is one thing.
They're ready for solar eclipse delay at Volcano Stadium.
But seeing it in action is a whole other ballgame. And on April 8th, you can see just what I mean as a total solar eclipse crosses the United States. NASA has mapped the detailed shape of the moon's surface, so we know exactly where the moon's shadow will fall. And you know where to be to see the eclipse in person, even if it's from the stands. Don't miss your chance to experience the beauty of science in action and maybe catch a ball game.
You actually can't see it. We are 2 minutes, under 2 minutes actually, away from totality here in Kerrville, Texas, which will mark the start of our eclipse coverage across America. Now, folks, we have a little bit of cloud coverage right now in Kerrville, so we are showing the Dallas feed. But again, we're holding out hope. Gina and I are thrilled to be here with Dr. Nicola Fox, who is the Associate Administrator of NASA's Science Mission Directorate. Nikki, thank you for being here.
Oh, I wouldn't be anywhere else. Thanks for being here, Nikki. So tell us how the science conducted today will really impact the future of exploration at NASA Science.
Oh, wow, there's so much that we're going to be doing today. We're going to be studying the sun. We're going to be studying the Earth's atmosphere and how that changes. You can see it getting dark here. And, you know, we've got these little magnetometers. They're going to be all across. We have 30 of them all the way across. I'm going to hold it up.
Very nice. Love magnetometers.
Magnetometers, and we're gonna be having these all the way across the path of totality. And it sounds like we should go. We should get up.
All right, let's go.
Let's go. Oh my goodness. Less than a minute. Oh my goodness.
Wow.
Okay.
All right, glasses on, Nikki? Yes?
Yeah,
or
glasses
no?
on, but we're about to get yeah.
There's some cloud
there's
coverage.
some cloud coverage.
It's trying to peek out.
It is trying. It is trying. It is trying.
Windy,
it is getting
for
dark
sure.
here. The wind's picked up. You could actually see the birds started flying in a very weird pattern a minute ago.
Good point.
Come on, clouds.
Everyone's
Wow.
screaming.
Yes.
You know, I might have to switch to Team Sun.
Come on. Oh my goodness. We're there. We're nearly there. Okay.
Here we go.
Wow, the crowd is counting down.
Wow. Yes.
Oh my gosh, it's beautiful.
Yes.
Oh my goodness.
That is amazing.
Wow.
I told you. No, go away, clouds. Go away, clouds.
They're
Look
gonna
at
move.
that. Oh my goodness. I have been saying all day. Look how dark. Look how dark it is around here. Yeah.
It is just this white ring.
White ring.
Yeah, it's so dark.
It is so dark. It is
You
so
can see
dark
the planes
here.
and the sky
You
much
can.
better.
Wow.
You can.
Everybody's
We have
just
planes and
screaming.
helicopters and drones
The whole
all over the
crowd
place
is
today.
just
Look
Here we
at
go.
the clouds are going to clear
Look
for
at
us.
that. Yes. Yes. Woo! Woo!
Oh my
Look at that. Just
That's
look
amazing.
at that. That is
And we have
incredible.
about, what, 4 minutes
Oh, yeah.
to
4
just
minutes
bask.
and 25 seconds.
To be exact.
Yes.
I mean, this really,
Yes.
again, reminds you that we are on this one planet, you know,
Yes.
in this larger system.
And you have to be on this planet to see what we're seeing.
You do.
right now.
That's why we are Team Sun, Earth, and
Sun.
Moon. Because you need the moon for an eclipse. You need the sun for an eclipse. And we're
Right.
standing on the Earth to see it.
Oh man.
So, all of NASA
Amazing.
science represented by a total solar eclipse.
And something that, what, over 30 million of us today, at least in
at
the
least.
path of totality.
At least, yes.
Able to
Yeah.
witness this.
I don't know
31
about
people
you,
living in the path of totality. So
Doesn't
imagine
count
how
who
many people
travels.
actually traveled here. Yes.
Absolutely.
Yes.
This
Wow.
is getting me extra excited about all the science that
All the science that we're doing.
right?
Yes. Yes.
All right, those clouds are playing tricks
Those
on us
clouds
now.
are being pretty mean. Yes.
It was nice to get a taste, though.
It's
Wow.
true.
It is
Yes.
so dark.
It is.
We've got everybody
is
looking
so
up.
dark.
I'm so happy that, you
Yes.
know, for
So
folks that
good.
travel,
Yes.
able to see this take place.
That's right.
And
so-
it's been such a
waiting.
great atmosphere here all day. Every
Yes.
time the sun comes out, everybody
Everyone's
cheers.
cheering,
Yeah.
counting down. It has been incredible. And so, wow.
That's true.
Oh, Nikki, what's your favorite part about these? About an eclipse? Is this your first?
No, this is my second one. 2017. I was in Nebraska and I saw it there. But I think there's just you can study the sun, you can study the corona, but suddenly you see it with your own eyes, and it's that feeling of just, wow, that is our star. Like that isn't just, it isn't just the sun anymore. That's a star, and you see it looking like a star. And, you know, as we study, you know, as we look for exoplanets in other galaxies that might be able to support life, you know, we need to understand our relationship here on this planet with that star. And
That's
so
right.
it's just, it's so important. And I think when you see it, you're just like, wow, it actually is a star.
Yeah.
You know, it's not just a bright point of light in the sky. You can see the structure. You can see just how exciting the sun is, and actually how dynamic it is.
Yeah. And you know, it's not often in heliophysics that we can actually see the science that we're doing with our own eyes.
That is right.
So it's
That
a
is
rare
right.
experience.
Or even sharing it, you know,
Yeah.
millions of
Have
us
so
today.
many people partake.
Yep.
That's right. It's pretty windy too here.
It is windy.
And so I know earlier in the show we've mentioned that total solar eclipses really might only pass through a certain location, say every 375 years.
Mm-hmm. Yeah.
Can you explain how come we don't see eclipses like this every day?
month?
Yeah. Every month.
Because the moon's orbit is actually tilted, and so most of the time when it passes in front, it doesn't block out the light for us. At this particular time, it is right on the plane between the Earth and the Sun. It is actually at its closest point to the Earth, and so in the plane of the sky, the moon is exactly the same size as the sun, and that is very unique.
That is so special too.
Yes.
I mean, like, what are the odds?
It's the 400s, right? It's
Yes.
The distance between the Earth and the Moon is 400 times closer than the Earth and the Sun, and the size is 400 times smaller as well. So it just blocks it perfectly.
Yep. It does, and right now the clouds are blocking it perfectly.
Hey, but we got a taste of it, which
We
was
did.
very nice,
True.
and we are
We
chasing
did.
this eclipse across North America
We
today.
are.
So excited
Yeah,
to
we
see it
are.
from these
I
other
think
it wants to
locations,
come
too.
out again. I don't know. These clouds are thinning.
Yeah, the clouds.
You can hear the crowds cheering.
The crowd's getting excited.
We're hopeful.
Yeah.
Channeling all that good energy.
Yeah. This crowd has been great all day.
Oh, yes.
All day.
It's crazy to believe, too, that it was so dark and it's only like midday.
Oh, yes. Yes. Yeah.
Wow, and we're starting to get some of this.
Starting to get the light back.
Yeah, starting to get the light back.
Yep. So unfortunately, we did not see the diamond ring at the end of the eclipse because of the clouds, which is always a crowd pleaser. But we did see it actually
saw it in the
right
beginning.
before totality. There was suddenly this beautiful bright one light, and then it all went dark. So we did actually see quite a few great features on the sun, and somebody actually was saying they could see a sunspot. Obviously through their glasses, but they could see a sunspot. So yeah.
So can you clarify what the sunspots are for our viewers?
Yes, absolutely. So if you were looking through your glasses, you might have seen a couple of dark spots on the sun. They are actually very intense places. There's very, very intense magnetic field there. They're very active, and that is what can cause space weather. So every now and again, those active regions can sort of explode and then send billions of tons of solar material towards our planet.
Wow.
Well, this was fantastic. Thank you so much,
Thank you,
Nikki. This was
Nikki.
incredible to experience this with you. Let's follow this eclipse right up that path. Next up is Dallas. We have Joy and Michael standing by for their big moment in the sun.
Yeah, you can feel the temperature change. The wind has completely quieted down. Yep.
So the energy here is amazing. So with me right now is Dr. Michael Kirk. He's one of our eclipse experts. Michael, we saw an annular eclipse back in October, but
Yes.
today is a total eclipse. How are you feeling today?
It is totally different. I am ecstatic. The annular eclipse was really cool. This is, you can feel it, the energy here is electric.
If you look around, you can see that the darkness is coming. Let's have a quick look at what we're looking at right now. We're almost there. We're a couple of minutes away.
Ooh, yep. Just a crescent left.
So let's quickly talk about some of the ways that the public are participating in the eclipse right now.
Yes.
Michael, can you talk about some of the citizen science projects?
Yes, there are people all around the country right now making measurements of audio recordings to see how the environment is changing. And it is a great opportunity to do genuine science with just an audio recorder.
Fantastic. So we are almost like, let's see, a few minutes away. So minute
just a
30
minute.
out, I think, actually. So let's have a look at the eclipse. Michael, what should we expect to see moments before totality?
Okay, so as we approach totality, you're going to see that crescent sun slowly drift away, and then you're going to see the Bailey's beads, where there are these bright points of light that are last bits of sunlight cascading through the moon valleys. And then right before totality, you'll see a diamond ring, that last single point of light, and then we'll be in totality. We just have a thumbnail of sun left. We are closing in on totality here.
Wow, we see a slither of the sun left. Remember, you can only take your safety glasses off when the moon has completely covered the sun. And in Dallas, Texas, we are seconds away.
Oh my goodness, I can feel my heart racing. You can hear the crowd getting excited. The birds are chirping, and they seem like they're going into their nighttime routines.
Wow. So we are a few seconds away. You can hear the crowds cheering.
Here we go. Oh my goodness. This is absolutely ecstatic.
The darkness is coming over Dallas.
Here we are. Just a few seconds left.
10 seconds.
Woo! Oh, I'm so excited.
Okay, we are 5 seconds away from totality.
One little bit. It's totally dark here. Deep twilight around here.
Wow. You can hear the crowd.
So the last bit of lights, and we're in totality. Woo! Oh my God.
Oh my God.
That is absolutely breathtaking.
Oh my God, Michael. How are you feeling right now?
I am just awestruck. I mean, there's a few high clouds, but the beauty of the corona is clearly visible. You can see that spiky structure just poking out. It is heart-stoppingly beautiful.
Oh my goodness, I have tears in my eyes. I was not expecting this.
This is one of those experiences that you just never forget. I feel so special to be right here, right now, experiencing it, and knowing that people literally across the nation are doing the same thing it's truly amazing.
Wow, let's take a moment to take it all in. This is absolutely breathtaking.
Wow. You can see that spiky structure of the corona. That's indicative of our approach to solar maximum. That asymmetrical nature of the corona happens when we're in solar maximum, and that's going to be happening in about a few months from now. So that means that this view of the corona will never happen again, ever. This is a completely unique view that even if you see a million solar eclipses, you'll never quite see one like this.
So, Michael, you study the sun. What is it like to see the corona that you don't normally see?
I mean, there are no words. I spend my life studying this thing, and to be able to see it and feel it it's just tremendous. You can see a prominence in the chromosphere, the middle atmosphere of the sun is a pink spot, and that pink loop is what I spent 5 years doing a dissertation on. that one little pink loop, and it makes it all feel like it's in perspective now.
I can't believe how clearly I can see those pink loops and the structures in the corona.
We can see a few planets out as well. They're brightly shining in the sky, and actually there's a plane racing across the shadow as we speak as well.
And I just want to take a moment to say huge thanks to our telescope operator, Vanessa Thomas, for providing these views. This is just so stunning.
People are applauding here, as you can hear. I mean, I think everyone here is getting exactly what they came for, which is just that sense of your place in the universe. This is our closest star, and being able to see the star like this is truly special.
Okay, we have 1 minute left of totality.
Oh, the time just passes way too quickly.
The next eclipse won't happen across the U.S. for another 20 years, so this really is a once-in-a-lifetime opportunity for a lot of people.
Absolutely. Our friends up in Alaska will see their next eclipse in 2033, so I am like already thinking I need to go there. I mean, it's just
Yes, definitely.
it doesn't matter what I need to do. I just have to go there.
Wow. So we're 30 seconds out.
Oh, my
so
goodness.
right before totality ends, our telescope operator, Vanessa, is going to put the solar filter back on. But let's just cherish these last few moments of totality in Dallas, Texas. Michael, what will happen right before totality ends?
So as totality's ending, we'll go through the process in reverse. You'll see maybe a diamond ring, a few Bailey's beads as the sun creeps out of totality. And then we're going to go back into a crescent sun again. Okay, and there's a diamond ring again. So
Okay.
time to put your glasses back on. And that
Sunglasses
is
back.
it.
Sorry, eclipse glasses back on.
And it's coming back
Wow.
again.
Wow, the slither of the sun
And you can
has
see
come
shadow
back.
bands on the ground right now. It looks like it's almost raining, or you can see those shadow bands racing across the ground as we come back in out of totality.
Wow. Whew. Oh my goodness, Michael, that was amazing. I was not expecting to feel so emotional. I still have tears in my eyes.
It just grabs you. It is unlike anything else. It's as amazing as seeing anything in the natural universe. Like I said, there are no words.
Michael, thank you so much for being with us in this very, very, very special moment.
I feel honored to be here. We truly are in a special place in the entire universe right here, and I'm just so happy to share it with you.
So now let's head back to James at NASA's Kennedy Space Center, who's with the Eclipse moon. He's tracking the shadow moving across the U.S. James, how are things looking on your end?
Yeah, wow, Joy and Michael, really cool view there. It's insane to see just how dark it gets. It's literally like nighttime there. You can hear the birds chirping in that shot as well in the gardens. Absolutely beautiful. We got a bunch coming up in just a few moments here. Our next eclipse path target here for the NASA broadcast is in Russellville, Arkansas. They're going to have a long window too, 4 minutes and 12 seconds. They're expecting that totality kickoff at 1:50:05 to be exact. Again, you can continue to track this with our eclipse tool here. This is at go.nasa.gov/Eclipse Explorer. And you can see just how quickly it's moving. I'm playing this in real time. You can see that shadow. It's already moving very quickly to the northeast. And the fun isn't just for our friends on the path of totality, and there are a lot of people on that path of totality. About 31 million people reside somewhere on that path of totality. But there's a lot of people obviously outside of that path as well too. If I put on this overlay here for the percent coverage, a lot of folks, us included here in Florida, are experiencing that partial eclipse. As always, if you are in a partial eclipse, be sure to be wearing those eclipse glasses to protect your eyesight as you're viewing it. But you can see these bands here are greater than 75% view. So say you're watching up in, I don't know, Milwaukee here, for example. You've got a great view, almost 100% coverage. You're not quite at totality. 89.4%. Looks like you got good cloud cover there. 20% cloud cover. So hopefully you got a nice view up there as well, too. I've also put on this overlay here to show you just the amount of the duration of totality. You see a lot of our places are within this middle band right here that are getting more than 4 minutes. It may seem like a lot of time, but as you've seen just how quickly that can go by. Michael sounds like he wrote his whole dissertation, a 5-year piece on those just few moments there. This just passes so quickly. And again, if you miss this, the next time you're going to have to wait for this in the U.S. is not going to be until 2045. So again, make sure you're previewing exactly when to expect that peak time of coverage wherever you are in our path of totality or even outside of that path of totality. So a lot coming up very soon. Again, our friends in Russellville look like they have great coverage there as well too. Only 9% cloud cover, so hopefully they're getting a really nice view. But let's check in with Jasmine up there to see. Hopefully you're looking good for there. How's it looking up in your way up in Russellville?
I'm just looking this way.
Everything is looking absolutely fabulous here in Russellville. We could not have asked for better weather. So we are back here in the downtown depot area, and joining us now is heliophysics expert Dr. Patrick Kane, all the way from DC. How are you feeling about your very first total solar eclipse?
I'm incredibly excited. As I'm watching all of the changes, there go the crowd. As I'm watching all of the changes, I'm thinking back to the textbooks that I've read, and this is, so it was all academic before. This is no longer academic.
Yeah, so the feeling is very different than what we might read in a textbook. Patrick, just explain, describe the atmosphere around us as it's changing.
Right now, as I'm looking around, of course, the temperature has been falling for the last 20 or 30 minutes, but the light is dimming, and it's dimming faster and faster and faster. It seems like it's accelerating. The crowd is definitely getting excited. I'm looking around the ground to see if I see the shadow snakes. I don't, but this is just really exciting.
It really is. Honestly, like you said, we're feeling that cooler weather.
Yeah.
The crowd behind us just erupted. We're also feeling them fall a little bit quieter, too.
Right.
So we're going to take a beat of silence as we get into totality. I think we're less than about 15 seconds away. So we're going to also look over our shoulder with our solar eclipse glasses still on until we are in totality. Here we go. Just a sliver of the sun left.
Getting close. Crowd's getting excited.
The crowd, yeah, all around is completely electric.
Going. Wow.
Oh my goodness. Here we are.
Here we go.
And the crowd goes wild.
God. Oh my God.
Wow.
We got some Bailey's beads. Oh,
absolutely stunning.
That is spectacular. We see Venus over to the side there.
And Patrick, it came and went so quickly, but we did see a diamond ring at the very beginning there. Can you describe to us what is that?
Sure, that diamond ring effect is due to the moon not being perfectly smooth. It's got mountains, it's got valleys. So just like here on Earth, when we see a sunrise or a sunset through a valley, we just watched a sunset through a valley on the moon.
Absolutely stunning.
Oh my.
So you said we could see one planet. I see it right there in the sky. Can we see any others as we're looking up?
Yeah, we've got Venus on the over to one side. We've got Jupiter up here to the left of the sun. And there's the corona.
Absolutely beautiful.
That is spectacular.
Now, you also said that this is happening during what we're calling a solar maximum. Now, Patrick, does that mean that the sun is stronger right now than normal?
Not so much stronger, just more dynamic. It's changing a lot. During solar maximum, the magnetic field on the sun is more chaotic, it's more disorganized. So you see more random directions for the jets of gas leaving the sun.
Right.
That is spectacular. We could see a stream.
All right, we are reaching that halfway mark already, 2 minutes into totality.
There's even just a hint of a diamond ring down at the bottom.
I can see it. Yeah, we're looking at a diamond ring from Arkansas, the Diamond State. Now, Patrick, of course, as we've been talking about it, this is part of what we are calling the heliophysics big year. You are a heliophysics extraordinaire all the way from Washington, D.C. So what does that mean?
Okay, so the heliophysics big year started out in October of last year with the annular eclipse. And of course, we take a pause here in the middle to watch this particular eclipse, but then it will end on December 24th of 2024 when Parker Solar Probe passes as close as it's ever going to get to the surface of the sun within 9 solar radii.
Oh, wow. And I'm sure that means a lot to you because you worked on Parker Solar Probe about 20 years ago during its inception. So tell us a little bit more about that.
I worked on a concept study for Parker Solar Probe back when I was a graduate student in around 2002 or so. And back then, the idea was for it to actually dive into the